So the next type of configuration what you are going to study in your CMOS is your CMOS NAND gate. Okay. The first type what we have studied is CMOS inverter and CMOS. Now you are going to study CMOS NAND gate. So you know that what is your output of your NAND gate? NAND gate inversion of your AND gate, opposite to that of your AND gate, right? A, B. And if it is Y, what was your output? 0, 0, 0, 1, 1, 0, 1, 1. So this was your A, this was your B, and if what will be your Y? Opposite complement of your AND gate. 0, 0, it is a dot product is 0, complement is 1. So you will be getting 1, 1, 1, 0. So this is going to be your output in the case of your CMOS NAND gate. Okay, 1, 1, 1, 0. When your input is 0, 0, 0, 1, 1, 0, 1, 1. So you have basically you will have 4 transistor Q1, Q2, Q3, Q4. Okay, so your transistor Q1 and Q2 is your P channel enhancement MOSFET and your Q3 and Q4 is your N channel enhancement MOSFET. Okay, so how is this configuration? To P channel will be connected in parallel and to N channel will be connected in series. So Q3 this will be your N channel and your Q1 and Q2 will be your P channel. So it is connected in parallel and here it is connected in series. So what will be your connection? This is going to be a source, drain, drain. Here it is going to be your drain, source. Here it is going to be your drain, source. Okay. So this is how your configuration, and what are the inputs? A and B is your input. The same input A is given to your Q1 as well as your Q3. Similarly, the same input B is given to your Q4 and your Q2. So here you can draw it in different way also. A input, if you want, you can give here B separately. Similarly, here you can give A separately. Okay, and the output is taken across this point. It is your taken as your V0. Okay, so let me tell, these are some of the important points. It consists of 2 P channel and 2 N channel enhancement MOSFET. P channel MOSFETs are connected in parallel and N channel MOSFETs are connected in series. Okay, Q1 and Q2 are P channel MOSFETs and Q3 and Q4 are N channel MOSFET. Okay, so you know the basic working principle of your P channel. As I have mentioned in the previous video, P channel, your transistor will be on when your input is low. Okay, and similarly your N channel, your transistor will be on when your input is high. Okay, so this is your P channel and N channel working principle. So how can you write your truth table? If I'm going to take 2 inputs A and B, what are the 4 combinations? 0, 0, 0, 1, 1, 0, 1, 1. Whenever the input is low, your transistor Q1 and Q2, that is your P channel, will be on. Whenever your transistor is high, your Q3 and Q4 will be on. So if any one of the transistor is low, what will happen? The corresponding P channel transistor will be on. For example, if A is connected to your Q1 and if A is low, then Q1 will be on, right? Similarly, in this case, B is equal to 0. So B is connected to your which P channel? Q2, right? So Q2 will be on. So when B is equal to 0, Q2 will be on, right? So these are the, and here in this case A is equal to 1. So when A is equal to 1, which N channel will be on? A is equal to 1. So Q3 will be on. That is the reason why Q3 is on. So let us go one by one. Okay, so let us take the first case when A and B is equal to 0. Both A is equal to 0, B is also equal to 0. So when A is equal to 0, low, P channel will be on, right? So Q1 will be on. Similarly, B also is equal to 0. So Q2 also will be on. When A is equal to 0 and B is equal to 0, N channel will be off. That is the reason why here you have both is in the off condition. Now when your Q3 and Q4 is in the off condition, what will happen to your output? This will be open. This will be closed. So all the VDD will come here. V0 will be equal to VDD. That is the reason why you are getting it as high. Let us take the next condition. A is equal to 0, B is equal to 1. So when A is equal to low, Q1 will be on, right? And B is equal to 1. Since B is equal to 1, Q2 will be off. Similarly, let us take for N channel. When A is equal to low, Q3 will be off, right? And when B is equal to 1, your Q4 will be on. Okay. So now what happened to your output? In either of the two cases, if either any one is in the on condition and one is in the off condition, it acts as an open. It will not connect to the ground. Okay. So your output will always be high in either of these cases also, 0, 1 and 1, 0. So now let us take the third case. In this case, your A is equal to 1, B is equal to 0. When A is equal to 1 means your P channel will be in the off condition. Your N channel will be in the on condition, right? Q3 will be equal to on. Similarly, when B is equal to 0, now here second case B is equal to low means which P channel will be on? Q2 will be on. When B is equal to low, Q4 will be off. So in this case also you have one, that is your Q4 is in the off and Q3 is in the on. So it will not connect to the ground. Okay. So your output will be high. V0 will be high. But you take the last case when both is equal to 1. A is equal to 1 and B is equal to 1. Both these transistors will be in the on state. It will get shorted together and your V0 will be connected to the ground. That case these two will be open circuited. So V0 will be equal to 0. That is the reason why only for the last condition you are getting V0 is equal to 0. So these can be explained by three cases. Case 1, when the inputs are low, Q1 and Q2 are on, Q3 and Q4 are off, first case. Okay, and the output is VDD. Similarly, for the second case, this is your second case, either of. When any one of the input is low, then that corresponding MOSFET's Q1 or Q2 is on and Q3 and Q4 is on and the output is high. Case 3, when the inputs are high, what will happen? Q1 and Q2 will go off and Q3 and Q4 will go on. What will happen to your output? Output, your Q3, Q4 is shorted, right? So it will be, V0 will connect it to your ground and you will be getting output as low. So this is your working principle of CMOS NAND gate.